Hey guys, Mr. Backenberg here. In this video we're going to look at the composition of functions. So when we're looking at the composition of functions, it's another operation that we can use to combine different functions, but it's very different than adding, subtracting, multiplying, or dividing functions. So if we have two functions, f of x and g of x, then function composition is f composed with g of x, and that's defined as doing f of g of x. So what that means is when we're doing f composed with g, we're going to be taking whatever our g function is and plugging it into our f function for the x values. So let's look at an example in here, and let's say my f of x function is e to the x. And then I'm going to say that my g of x function is the square root of x. And what I want to do first is I want to do f composed with g of x. So that means that I'm going to take my f function and I'm going to plug in my g function. Okay, so my g function is the square root of x. So I'm going to be doing f of the square root of x. So here's what I'm going to look at doing. My f function is that e to the x. But what this is saying right here is that I need to take my f function and everywhere I see an x in it, I need to replace it with the square root of x. So up here where we have our x, I'm going to get rid of that and I need to replace it with what's inside of my parentheses here, the square root of x. So I get e to the square root of x when I do this composition. So f composed with g of x is equal to e to the square root of x. But I could also do this the other way around. If I wanted to, I could do g composed with f of x. And what that would mean that we're doing is we're starting with our g function, but then we're plugging in our f of x function. So we're going to be doing g of my f of x function is e to the x. So I always like to start by writing down the first function that I'm dealing with. So that's my g function. So that's the square root of x. And what this is saying is that I need to plug in the e to the power of x for that x value. So I'm going to go and I'm going to erase that x again, and I'm going to replace it with my e to the x since that's what's inside of parentheses. So this time, g composed with f of x is equal to the square root of e to the x. And we should notice that we're getting different answers depending on the order that we're doing the composition in. When we did f composed with g, we got e to the square root of x, but when we did g composed with f, we got the square root of e to the x. Because we're getting different answers, that means that composition is not commutative. Now we're going to look at another example with function composition, but this time as we're doing it, we're going to focus on finding the domain of the answers that we get. So I'm going to look at two functions here. My f of x function is going to be x squared minus 1, and my g of x function is going to be the square root of x. And what we're going to do first is we're going to do g composed with f of x. So this means that we're going to take our g of x function and we're going to plug in our f of x. So I always like to start with my outer function, so that's the square root of x. But what this is saying I need to do is I need to get rid of that x underneath my radical, and I need to plug in my f of x function, which is x squared minus 1. Now when we're talking about the domain for composition of functions, we actually want to start by looking at the domain of our original functions. So if we look at f of x, remember when we're checking for domain issues, there's two big things we're looking for. We're looking for fractions because we need to make sure that we're avoiding dividing by 0, and we're looking for square roots to make sure that we're not square rooting negative numbers. Our f function doesn't have either one of those, so our f function has a domain of all real numbers. Now if we look at our g function, we see that square root in there, so we need to make sure that we're not square rooting any negative numbers. So the domain for g is going to be x values that are greater than or equal to 0. Now when we're looking at a composition function, so here we were doing g composed with f, so we were taking f and we were plugging it into g. What we want to look at first is we want to look at the domain of the inner function first. So here our f function had a domain of all real numbers, but then we want to look at our answer that we get once we do the composition, because sometimes we're going to have to restrict down the domain a little bit more. Now if we look at the answer that we got in here, we got the square root of x squared minus 1. And because of that radical, we need to make sure that the stuff underneath the radical, the x squared minus 1, isn't going to be negative, so it has to be greater than or equal to 0. So the domain for this one ends up being the x values that run from negative infinity until we hit negative 1, and then also from 1 up to positive infinity. So we started with the domain from our inner function, which was all real numbers, but then we had to restrict down the domain because of the answer that we got once we did the function composition to being just the x values that run from negative infinity to negative 1 and then from 1 up to positive infinity. Now if we do the composition in the other direction, so if we do f composed with g of x, this is saying that we're going to start with our f function, but then plug in our g of x function. So my f function is the x squared minus 1, but I need to get rid of that x and replace it with what the g function is equal to, so that's the square root of x. So we get the square root of x squared minus 1. And we can actually simplify this down a little bit because the squared and the square root are going to cancel each other out. So we just get x minus 1. But now as we're talking about the domain, we need to start with the domain of our inner function. And our g function had a domain of x values that are greater than or equal to 0. And then we look at our answer to see if we need to restrict down our domain any further. This one doesn't, because there's no square roots left in there and there's no fractions in there, so we don't have to worry about excluding any values. So it's just going to be those x values that are greater than or equal to 0. Now we've been working on taking and putting these functions together, but sometimes it's actually helpful to identify that composition has happened and break that function down into maybe two smaller, easier to work with functions. So we're going to look at a function h of x, and h of x was created by doing f of g of x, and what we want to do is we want to figure out the original f and g functions that would give us h of x when we do the composition. So we're going to look at this function h of x equals x plus 1 squared minus 3 times x plus 1 plus 4. And we're going to try to break this down into two smaller functions, f and g. And what we're going to look for first is our g function. So we're going to look for another function that's being plugged into something else. And usually a big clue that something is being plugged in is a set of parentheses. So I actually see two sets of parentheses in here. I see one around this first x plus 1, and then I see another set of parentheses around this other x plus 1. So it looks like we're plugging in x plus 1. So that's going to be my inner function. That's going to be my g of x function. So x plus 1 is the g of x function. Now to figure out what f of x was, is we're actually going to get rid of those sets of parentheses and just replace them with plain x's. So if I get rid of that first set of parentheses and just replace it with an x, then I just get x squared minus 3 times, get rid of this set of parentheses and replace it with a plain x, and then on the end I just have plus 4. So my f function is x squared minus 3x plus 4, and my g function that got plugged into that is x plus 1. Now I'm going to give you a new function to look at. Here we have h of x equals the square root of x cubed plus 1. And again, we're going to try to break this down into two smaller, maybe easier to work with functions, f and g. Now in our first example that we looked at, we had these sets of parentheses which told us that this x plus 1 was being plugged in. Here we don't have a set of parentheses, but we've got this stuff happening underneath our radical. And square roots actually work as grouping symbols as well. So here my g of x function is going to be the stuff underneath that square root. So it's going to be the x cubed plus 1. And then for my f of x function, I'm just going to remove that stuff from underneath the radical and replace it with a plain x. So that's just the square root of x. That's going to be it for this video. Thanks for watching.